Okay, class, in this lesson, we are going to learn to use transformations, which is translations left and right and up and down, to analyze and sketch graphs of trig functions. So let's go ahead and get started with the first example. Okay, so in this example, we're going to understand their phase shift as a horizontal translation, okay? And here's the question. How does changing the value of h affect the graph y equals sine parentheses x minus h, okay? So what we want to know is if we have a function 2 sine x minus pi over 2, what does this do to the function? Well, first what we're going to do is graph what I consider the base function, okay? So without the shift, okay? So we're going to just graph this. And if we were to graph this, we'd see that this is because of this 2 in front of the sine function, this coefficient is a 2, so that tells me that my amplitude is going to be a 2, okay? So with sine functions, we always start at the origin, so we're going to plot a point there, and then at pi over 2, we're going to reach our maximum amplitude of 2, and then at pi, it's going to be 0, and then at 3 pi over 2, we're going to be at negative 2, and then at 2 pi, we go back to 0, okay? So the graph of this function would look something like this, okay? So that's our y equals 2 sine x. Now, the question here is, what happens when we incorporate a negative pi over 2, okay? So when we have a negative pi over 2, what ends up happening is this entire function actually shifts to the right by pi over 2, okay? So if we were to graph the blue function, now we would start at pi over 2 comma 0, and then at pi we would be at 2, and then at 3 pi over 2 we'd be at 0, and then at 2 pi we'd be at negative 2, and then at 5 pi over 2 we would be back to 0, okay? So this function would look something like so, okay? So what we see is this is what's considered a phase shift of pi over 2, okay? So it's shifting to the right by pi over 2. Notice that this is a negative, okay? So when you have a negative in this parentheses, in this trig function, then the shift would be to the right. If it were a positive, then it would be a shift to the left. Okay, let's take a look at example number 2. All right, so now we're looking at a vertical translation, okay? And here's the question. How does changing the value of k affect the graph of y equals 2 sine x plus k? All right, so just like the previous example, we're going to go ahead and graph this function first, okay? So again, we have an amplitude of 2. So we're going to start at 0. This goes up to 2 at pi over 2, back down to 0 at pi. Then it goes down to negative 2 at 3 pi over 2, and then back to 0 at 2 pi. Okay, so if we were to graph this, it would look something like this. All right. So that is our y equals 2 sine x. Now, if we were to take into account this plus 4, what this means is that this is going to be a vertical shift up by 4 units, okay? So instead of it starting at 0, 0, we'd start at 0, 4. Okay, so everything basically moves up by 4 units. So at pi over 2, it goes up to 6. At pi, it goes back down to 4. At 3 pi over 2, it's going to go down to 2. And then at 2 pi, it goes back up to 4, okay? And so this function would look just like the one that we drew in black, but shifted up by 4 units. Okay, so this is a plus 4. Notice that when we have a plus 4, it goes up 4. If this were a minus 4, then this would obviously shift down 4 units. Okay, also notice that the midline, instead of being on the x-axis, the midline is now at y equals 4. Okay, so that's another way to help you draw. If you wanted to understand the shift, you could also move the midline and then use that as your reference line. Okay, let's move on to example number 3. All right, so analyzing a function. So here we have the function y equals 4 cosine 3x plus 1, okay? And here are the 4 components that we want to look at first. And the question is, what is the amplitude here? Well, the number in front of the trig function, this is the coefficient, is a 4, okay? So our amplitude is going to be an absolute value of 4, which is actually 4. And then the period, we want to look at the value just before the x, okay? Here we have a 3. So to identify the period, we're going to take the reciprocal of 3, which is 1/3, and we're going to multiply that by 2 pi. And that gives us 2/3 pi as our period. Okay, now we're going to look at our phase shift, okay? The phase shift would be inside the parentheses. In this case, there is no phase shift left or right, so we would say that that is just 0. And then our vertical shift. This is the number that follows after the parentheses here. It's all the way at the end, and we have a +1, so that tells me that our vertical shift is going to be up 1. Okay, so let's go ahead and graph this. So what I always do is graph the function before any of the shifting takes place. Okay, that's what I call the root function. And in this case, our root function is going to be y equals 4 cosine 3x. Okay, so with the cosine, we know that it's going to kind of look like a U, okay? Sort of a U. And the coefficient in front of the cosine is a 4, okay? So we know we're going to start at 4. Okay, so let's go ahead and start with the graph. So it starts at 4, at 0, 4, or 4 on the y-axis, okay? And we also know that our period is 2/3 pi, okay? So that means 1 full cycle is going to land over here. So we know that it's going to come back to 4 at 2/3 pi. All right, so midpoint between 2/3 pi would be pi over 3, and so we're going to be at the lowest point at -4, okay? Which means that between 0 and pi over 3, we're going to hit the x-axis right in that spot. So we can go ahead and plot that. And the same thing on the other side. We're going to plot that point. So then my function is going to look something like this. Okay? All right, now we're going to go ahead and graph the shift. So I'm going to do this in blue. This is now going to be 4 cosine 3x plus 1, okay? So everything basically shifts up 1 unit, and so all of my points are going to go up 1 unit. And what you'll notice is that the graph looks something like so, okay? So this one in blue is the function y equals 4 cosine 3x plus 1. Okay, so we've taken care of the amplitude, which is 4. We know that our period is 2/3 pi, and then a vertical shift of +1, and no phase shift. Okay, now part B, we have a different function. Now we have a sine function, and let's go ahead and identify these 4 components. So the first is the amplitude. We see that this is a -3. Okay, so the absolute value of -3 is 3. So we know our amplitude is going to be 3. And then for our period, we're going to look at the value just before the x, or the coefficient before the x. It's a 1, so my period is going to be the reciprocal of 1, which is just 1, times 2 pi, which means my period is 2 pi. Okay. My phase shift, we're going to look at what follows this plus sign. And we see that this is a positive pi over 2, so that means the phase shift is going to be left pi over 2. Okay. And then lastly, we're going to look at the vertical shift, which is this value here. And we see that that's a negative 2, so that means we're going to go down 2. Okay? All right, so just like the previous example, the first thing I'm going to do is graph the base function, okay? What I call the base function. This would be y equals negative 3 sine x, okay? No phase shift and no vertical shift, okay? Once you get more proficient at this, you don't have to graph it this way, but for beginners, I highly recommend that you graph the base function first so that you avoid any potential mistakes. Okay, so the coefficient in front of the trig function sine is negative 3, so instead of going up, we're going to be going down first, okay? So we're going to start at 0, 0, and that puts us right here, okay? Because we know that the period is 2 pi, we know that it's going to finish at 2 pi, 0, okay? Now, at pi over 2, we know that our amplitude is going to be 3, right, because of this. But it's going to be negative, so we're going to go down first. That means we're going to plot a point here at pi over 2. And then at pi, it hits 0. And at 3 pi over 2, it goes all the way up to 3. Okay, so our base function would look something like this. Okay, now we're going to take into account the shifting. Okay, y equals negative 3 sine, okay, x plus pi over 2 minus 2. Okay, so now what we're going to do is take each of these points that we plotted, okay, this is going to be our reference, and we're going to shift left by pi over 2, right, left pi over 2, and down by 2 units. So we're going to take this point, and we're going to go left pi over 2, so that's going to be over here, and then down 2, 1, 2. So we're going to plot a point right there. Okay, now we're going to take this point, and we're going to go over pi over 2 to the left, and then down 2. So it's going to take us down here at negative 5. All right, next point, we're going to take pi, and we're going to shift it over by pi over 2, and we're going to go down 2. 1, 2. Okay, so that puts us right here. And then we're going to take this point, and we're going to go over pi over 2, which takes us over here, and we'll go down 2. Okay, we're going to plot a point right there. And then lastly, we're going to take this point, we're going to shift left pi over 2, and then go down 2. So that puts us right there. Okay, and then we can go ahead and graph this. Okay, and the blue is the function that has an amplitude of 3, a period of 2 pi, a phase shift to the left by pi over 2, and then vertical shift down by 2. Okay, so hopefully that makes sense. Now you hopefully will understand why we start with this root function first, because this becomes our baseline, and then we use each of these points as our reference for our phase shift and our vertical shift. Okay, the other thing to note is that our midline is now right over here. Okay, I'm going to put this in dashed lines so you could see that this is a reference point. So you could also, again, draw the revised or the new midline to help graph your function. Okay, let's go ahead and move on to the last example. Okay, so in the previous examples, we started out with the function, and then you had to find the components and eventually graph the function. Here we're going to go backwards. So in other words, we're now given the graph. The next thing we need to do is find the components and then write the equation. Okay, so let's take a look here. First, we want to identify the amplitude of this function. Okay, the amplitude here is going to be to 1. Okay, up 1. But we have a this is up 1. So we're going to say our amplitude is 1, okay? And then our period, let's take a look. From here to here is roughly 2 pi. And how do we know that? Well, this is pi, right? Because we're going 1, 2, 3.14, and then, which is pi. And then if we go another 1, 2, 3.14, that takes us to this point. So then we know that our period is 2 pi. Okay, now let's take a look at our phase shift. Now notice that the scale here on the x-axis is not in radians. Okay, this is in just regular number or degrees. So this graph gives us the point 3, 0. So this tells us that the graph has shifted 1, 2, 3 units to the right. Okay, so that means our phase shift is going to be right 3. Okay. And then lastly, you notice that our midline here is on the x-axis, so there's no vertical shift. Okay, so we'd say that our vertical shift is 0. So if we were to write the equation, it would be in this form, okay? So we would write the following. We'd say that the function is y equals 1, which is our amplitude, sine, okay? Our period is 2 pi. So then our b is essentially 1. So we're going to say sine of x, okay? And then our phase shift. Well, what is our phase shift? We're shifting right by 3, so that's going to be a minus 3. Okay, and then vertical shift is 0, so that's going to be plus 0. So if we were to rewrite this, this becomes y equals sine of x minus 3, okay? And that is our function for the graph shown above. Okay, hopefully that made sense. If any of this was unclear to you, please go back to the beginning of the recording and listen to this again. Thank you.